Alright, so for the convex mirror, we're going to go ahead and draw this out. We're going to follow the same basic rules. Rule number 1 is doing what? Parallel line. So that's going to be the same. So go ahead and draw your parallel line from the object to the mirror. So that's beam 1. Now, what did we do after that? Reflected how? Through the focal point. However, notice there is no focal point on this side. Now, they might put one there to trick you, but there is no true focal point on that side. So, what you're going to do, if you look at the picture, how should this beam above reflect? Up, right? And so what you're going to do is you're going to aim it with the focal point. So it's still parallel focal, but you're aiming it with the focal point, and you're going to send it up this way. Okay, so everything is still aimed with the focal point. We're just sending it now up this way. So this one we can call beam 1, right? So it's still parallel focal, but it never goes through the focal. And that's the thing with these, is you should be drawing no lines through the focal point. The focal point's on the opposite side. Light doesn't go through mirrors, right? So it wouldn't make sense for it to go through it. Okay, what's beam 2 supposed to be? Through the focal and then parallel. So this is probably the one that people have the most trouble with. What you're going to do, especially when they try to trick you with the focal point on the same side, what you're going to do is you're going to aim it with the focal point back here, send your beam so it's heading towards the focal point. However, it never actually makes it to the focal point. It hits the mirror, right? So it can't make it to the focal point. So now it's going to reflect, and how's it going to reflect? Parallel. So now we're going to go ahead and reflect this beam parallel to our base. So that's beam number 2. So notice with this type of mirror, everything is aimed. Nothing actually goes through focal or center. It's all aimed with those. Okay, what's beam 3? Center to center, right? Beam 3 is center to center. So again, same thing. Aim it all the way back here towards the center. But don't actually draw it through the center. It's just aimed. And it's going to come back. This one's aimed all the way with the center back here. Okay, so as always, what are we looking for? A nice three-way intersection. What do you notice? They are diverging. So the beams are diverging. So again, the whole concept when this happens, imagine that this is your eyes. You're looking at this, and you see in straight lines. So what you're going to do is you're going to project back these 3 beams, 1, 2, 3, and look for an intersection over on this side. Okay, so let's go ahead and do that. Project back your 3 beams. Look for the intersection. So remember, it's always the reflected beams. Again, notice there's 1, 2, 3, 4, 5 beams. Be really careful. You're only doing these 3, the reflected ones, the ones that go through your eyes. Here we go. First one is pretty easy. You just go through straight, aim it to the focal. The second one is probably the one that people mess up the most, because they want to send it through the focal again. But We're sending the parallel one back. And lastly, the red one. This one's pretty easy too. Just send the red one all the way back to the center. Should already be aimed with the center. Okay, you should get a nice three-way intersection. This represents your image. Please make sure that you draw in the image. Don't just leave it as a dot. Draw the rest of the image in. So what do you notice about this image? Okay, small. Okay, what else? Okay, it's upright. It's on the opposite side again, right? And what do you guys think? Is this real or virtual? Virtual. Remember, whenever you project back, that's your brain's way of trying to see the image, and that means it has to be virtual. If your eyes aren't there, there's no image there. If I bring a screen back here and try to show it on the screen, nothing's going to come up. That's how you know it's virtual. Alright, let's do the math on this. Let's do the math. Same equation, but what's the twist? Negative focal. So make sure if you mess that up, you're going to get wrong answers. Actually, you're going to get the answer as if it was a concave mirror. So the negative focal tells you it's a convex type mirror. Alright, so what was our focal? 5. So 1 over negative 5 equals 1 over 6 plus 1 over di. So we didn't measure these. We got to see if Brittany's going to go 3 for 3. I'm getting about 1, maybe 0.9-ish. Let's see what the math says. Oh wait, I just measured the h. I'm getting about 2.6. What's the math say? Negative what? 2.72? Broke the streak. Negative 2.72. So that's what you should have gotten, about 2.7. Again, what is the negative telling us? It's behind the mirror. Okay, let's try our HI. HI over HO. What was our HO? 2. Negative DI. Negative 2.72. And our DO was this time 6. So what do you get for HI? Point what? Okay, 0.906. I think that's about what I got. 906. All right, and then lastly, let's get M. M equals HI over HO. HI is plus 0.906. HO was 2. Oh, what is the positive telling us? Upright, good. And our M is also positive. It's about 0.45. And again, what's the positive tell us? It's upright, and what does the 0.45 tell us? Smaller, yeah. So less than 1, anything less than 1, or between 0 and 1 is smaller, anything larger than 1 is larger. It's about half the size or so.